So, in today's lesson, what we're going to be doing is looking at, so we looked at energy stores, everything from gravitational, kinetic, and we're now going to look at a few individually and then from there move on. And what I mean by that is we must clearly look at each, not all energy stores, a few of the energy stores in detail. And that's what we're going to do. And I'm going to split it in two parts. And these parts are really, really, really important. I'm just going to make this a bit bigger. I think it's really small. So I'm going to split it into two parts. And these two parts are going to fall into, and I'm going to write this here because you guys are really young. And this is your first real exposure to physics. And you break it into two things. The first one is going to be understanding. All right. Have a picture in your head. Okay. And this to me is the most important, right? Picturing what we're talking about, what we're doing is the most important thing. It supersedes any calculation, right? Being able to do a calculation is fine. It'll get you so far. You'll probably pick up a grade 8 A-level physics and stuff. And just to me, it cuts out what makes physics powerful and interesting and fun. And I'm doing some absolutely interesting things with year 9, year 8s and 9s. And the stories of some people is absolutely amazing. So you've got to get a picture in your head. Secondary to that, and which we're also going to do, is be able to calculate. Now, this is using formulas. It will, as this probably is one of the first times some of you've ever used formulas in physics. But for me, as I said, the most important one is get a picture in your head. Okay? If you get a picture in your head and then you do a calculation, it makes so much more difference in understanding. All right, so let's go through this. What we're going to have a look at today is kinetic energy. And kinetic energy is all about, I'm just going to go down and see if I can get it done a different way. Kinetic energy is all about movement. All right. And I'm just going to move these down. I'm going to see if I can put another here. So kinetic energy is all about movement. Movement. Or moving. And to me, I have pictures in my head. So kinetic energy is movement energy. But what factors affect how much energy something moving has? And let's put that here. And let's make that a bit bigger. What factors? And what are my factors? What things affect how much kinetic, let's be careful, kinetic energy something has? Now, at this point, I want to do the first thing. Picture it in your head, right? Picture this in your head. Keep the language really simple. Keep the language personal to you. Talk about it or think about it the way that makes sense to you. Not how it makes sense to me or not anything that sounds good. If you want to try to make it all sciencey and sound sciencey, you're probably wrong. All right? So what affects it? All right? First thing, to me in my head, it's how fast something is going. Okay? So if my son's a big boy, 6'5", if he walks into me, right, there's going to be a bump. If he runs into me, that's going to hurt more. All right? So the first thing that affects kinetic energy is speed. And I'll introduce you to another word. We also call that velocity. There's a difference between these two words, and we will look at that at some point, and I might explain it next week or next lesson. I don't want to throw too much. So speed and velocity. All right? And that's really important. Let's connect this to this. So the faster, to me in my head, the faster something is going, the more kinetic energy it has. The faster something is moving, the more kinetic energy. And I think that kind of makes sense. You know, if you've fallen off a bike, I've fallen off a bike lots of times. If you're going slowly, it doesn't hurt that much. If you're going really fast, it really hurts. So the faster you're going, the more kinetic energy you have. Have a picture of it in your head. The second thing that really affects it is mass. All right. Now I'm going to be very careful with mass. Mass is not weight, and we're talking physics. We're not talking English here. So mass is in kilograms in physics. It is not how much something weighs. Right? And we'll look at that at some point. Weight is in Newton, but that's a different kettle of fish. So the more mass something has, the more material it has. And that makes sense as well. To me, I have a picture in my head. If a bike is moving at 2 meters a second and hits me, now big deal. If a bus is moving at 2 meters a second and hits me, that's a big deal. So in my head, I have this picture. The bigger something is, the more it will hurt when it hits you. Right? And these are really key. These are really important ideas. And for me, having that idea there is more important than a calculation. All right. So that's the first part. The second part, and actually, and you got calculator, you got questions on this. All right. So here, part 4, practice questions. These are your ideas, and then you have calculations. So let's talk about the calculations. You have the kinetic energy formula. It looks really tough. You may never have seen this before, but I'm going to explain it to you. So kinetic energy, KE. I like to write it as EK. That's just me. You'll see it in either of these forms. Is equal to half. And in algebra, I don't know how much algebra you guys have done. You might not have done any. When there's nothing written between things, it means times. Half times m, which is my mass, times v, which is velocity or speed, squared. If, and I don't blame you if you don't know this, if you don't know what v squared means, it simply means v times v. Okay. Now, we're not going to look at why v squared. Okay. So when I look at a calculation, and this is how you must do it. So problem, find the kinetic energy of a 6 kilogram ball moving at 5 meters per second. First thing, write down the things you know. This 6 kilograms is its mass. I will say this again, this is not its weight. English is not physics. Physics is a different language. Its mass is 6 kilograms. 5 meters per second is its velocity or speed. I'm going to call it velocity. I'm going to get used to it. Step 2. I'm not going to do it this way. All right. I'm not going to do step 2. All right. I'm going to do step 3. Write out the formula, but you're going to write it out this way. EK or KE equals a half times m, which is my mass, times v squared. And you're going to use a calculator. This is physics. I don't care if it's GCSE physics, A-Level physics, KS3 physics, you always get a calculator. M is my mass. Now let's change colour and colour coordinate this. My mass is 6. Here, 6 kilograms is my mass. So I'm going to write down EK, kinetic energy. Half is already a number. Half times my mass. I'm going to change that to blue so you can see where I've got that from. I've got that from here, 6. Go back to green. Times, oh dear, wrong green. Times velocity, which is 5, squared. You put that in your calculator. You don't do this. There's no need to do all this. You put that in your calculator and you should get 75. The units for energy is joules, and just put a J on the end of that. So I'm throwing a lot of things at you. It is new. This is just layout. Your job is part 4. Right? Easy questions. Part 5. All right, take your time. Now, before you start, I was teaching A-level physics this morning in Malaysia. Layout. This thing here, laying it out properly, is what makes somebody brilliant. You might be shocked by that. This has nothing to do with brains. People say physics is hard, but it really isn't. All right? And that's what you're doing. And the other thing I'm going to do with today's session, I'm just going to stop recording this. I'm going to